fatherland. The nation filled with heroes like the Superman. Welcome to my nation called Nigeria, a blessed nation and the giant of Africa. We work together to make our people live large. That's why we're beautiful and bold, we are strong black. And everywhere we go, we're making difference.
This presentation is titled Adoption of 3D Printed Adobe as Alternative Building Materials in Developing Affordable and Sustainable Housing for Refugee Settlement. This presentation is part of Eco-Village design concept, taught in ecological design principle of housing settlement. My name is USMAN Naibi. I am a PhD student at Istanbul Okan University. I hope at the end of this presentation you will learn a little about eco-villages and its planning principle. I also hope you will learn more about 3D printed Adobe and then the design of an eco-village using 3D printed Adobe to create an affordable and sustainable housing settlement. I also hope we will see more about the prospect of using 3D printed Adobe in future settlements. Thank you. We will highlight the definitions, problem statement, aims and significance of the research under the introduction. Then we'll talk about the theoretical background and then further case studies as evaluation. And finally, we'll look at the 3D printed Adobe application in refugee settlements. This research assesses 3D printed and its adoption to solve the global housing deficit. A qualitative case study approach was adopted to evaluate existing buildings made out of Adobe as an alternative building material to understand the dynamics and typologies of structures. The findings and results informed developing a prototype design for the adopting 3D printed Adobe as sustainable building material to tackle the global housing challenge. We will look at Eco-Village. Eco-Village is a community whose inhabitants seek to live in a way that has minimal impact on the environment. The designs are mostly traditional, intentional, and with a goal of becoming more socially, culturally, economically, and/or ecologically sustainable. The major concept of eco-village is the coexistence of living and non-living things in harmony by adopting. Eco-planning is done by associating natural cultural features, accessibility, creating accommodation capacity, and historical archaeological areas as a whole by preserving them. Environmental sustainability can be achieved by creating the use of villages together with climatic features, flora, fauna, aquatic features, land structure, natural and architectural environment. In terms of eco-village planning strategies, there are 9 basic working areas for sustainable planning. First, compact, balanced land use, vehicle use and easy access, rational use of resources, reduction of waste, prevention of environmental pollution, restoration of natural systems, good housing and living environment, healthy social ecology, sustainable economy, public participation, protection of local culture and social values. Introduction. 3D techniques have been adopted for different building materials, including concrete, plastic, Adobe, etc. Today, the vast majority of people on Earth live in homes made of earthen material constructed with Adobe. This research assesses the opportunities of the usage of 3D printed Adobe in developing affordable and sustainable housing for displaced persons. Majority of people in the world live in houses built using earthen materials. The reason for this is that the soil material can be found quite easily and abundantly almost everywhere. In addition, earthen buildings present more positive data to be obtained in terms of ecology and building biology than other structures using alternative building materials. A famous Egyptian architect Hassan Fathi, devised a method of constructing the Egyptian community of New Corner, close to Luxor, without the use of costly high-tech material like steel and concrete. Problem statement. One of the most daunting challenges of urbanization globally has been the provision of adequate housing that people can afford. Deficient housing can compromise life's most basic needs such as water, sanitation, safe food preparation, and storage, and their inadequacy contribute to the rapid spread of communicable and foodborne diseases. Refugees have the right to adequate shelter, which should be ensured in all stages of the displacement cycle. Findings from the United Nations Global Sample of Cities show that people across the world, all types of urban centers, are unable to afford home ownership or even the cost of rental housing. Nigeria, like many countries with humanitarian crisis, is affected by housing shortage for displaced individuals. A look at the map of Nigeria shows that there is an ongoing humanitarian crisis in virtually all regions, but most especially in the northeast region of the country. The aim of this research is to bridge the gap in adequate shelter through the adoption of 3D printed Adobe as building material in developing affordable and sustainable housing. A look at the global refugee and housing in historical context. The League of Nations came into being after the First World War. That the refugee issue came to be regarded as an international problem that had to be tackled at the international level. United Nations High Commissioner for Refugee Office was also established, and the United Nations Convention relating to the status of refugees was adopted in 1950 to 1951. Together, they offered a formal framework for meeting refugee needs and requirements for their protection under the international law. First, it offers a general definition of refugee as someone who is outside their own country and unable to return. Second, it acknowledges that those who meet the criteria for being considered refugees should be granted certain rights. Alternative building materials are those that have been developed through the modification of industrial materials that are typically used, unusual, traditional, or indigenous materials that are particularly appealing for use in homes. The main advantage are their simplicity in construction, wide availability, affordability, and low embodied energy, which frequently leads to lower embodied greenhouse gas emissions. Therefore, affordable housing is generally defined as that which is adequate in quality and location and does not cost so much that it prohibits its occupant from meeting other basic living costs or threatens the enjoyment of basic human rights. Look at 3D printed Adobe. This can be referred as the additive manufacturing of 3D material to create 3D shapes through series of cross-sectional slices. 3D printing with a material like Adobe is called contour crafting in building production. This image showcases contour crafting with mud using a Delta printer. Case studies were carried out to study 3D printing and 3D printing using mud in order to understand the constructability of the buildings using mud, space utilization, building performance, and effectiveness in construction. The first case study is the Tekla House in Ravenna, designed and built by Mario Cucinella Architects. Tekla, which takes its name from technology and clay, is the first and unique fully 3D printed construction based on natural materials and made with multiple 3D printers operating at the same time. Tekla is a circular housing model that brings together research on vernacular construction practices, the study of bioclimatic principle, and the use of natural and local materials. The earth mixture's composition adapts to the local climate, and the filling of the envelope is parametrically optimized to balance thermal mass, insulation, and ventilation in accordance with the climate requirements. The second case study is the new El Cosmico in Marfa, Texas. El Cosmico is a 21-acre nomadic hotel and campground located in Marfa. The project is jointly designed by Danish studio BIG Bjerg Engels Group and 3D construction firm Icons for Liz Lambert, a hotelier in Marfa, Texas. The architect creatively utilized the geometric shape to achieve various design concepts and inspiration, capturing the beautiful views using large windows, adequate natural light by a strategic placement of windows and skylights, using silo-inspired shapes to create privacy and to protect the building from solar heat gain. The team designed the structures using 3D construction technology informed by both the desert landscape and Bjerg Engels Group's work with NASA for moon-based structures. Third case study is called Casa Covida by Rael Sanfratello. This experimental case study house is designed and built in Colorado in San Luis Valley. In this project, Adobe is used as a combination of sand, silt, clay, water, and straw that is dried in the sun and it is a traditional building material of the region. The house comprises 3 spaces, each for 2 people to sleep, bath, gather around a fire and food, and the spaces have openings to the sky, the horizon, and the ground. A static 4-axis arm printer was used to facilitate multiple printing positions during the construction of this structure. As can be seen here, a double wall prototype is under construction, and the other image here shows a completed bath area. The 4th case study is called Gaia. Gaia is an eco-sustainable housing model using raw soil as the main binder and the use of natural waste material coming from rice production chain, all channeled to construct an efficient masonry structure from both bioclimatic and health point of view. Gaia is a highly performing module, both in terms of energy and indoor health, and almost zero environmental impact. It only requires a few weeks to build due to its masonry. It does not need heating or an air conditioning system, as it maintains a comfortable temperature inside both in winter and in summer. Detail showcases the acoustic and thermal insulation properties using the filling of rice husk and earth straw mixture. A summary of the 4 case studies was prepared, highlighting the building ecosystems in terms of their buildability, their energy management, their performance, and then also the individual strength, weakness, opportunities, and threats were summarized in the table above. We now examine the SWOT analysis of using 3D printed Adobe. In terms of strength, 3D printed Adobe natural and biodegradable material that reduces the environmental impact of construction. It can create unique and organic shapes that are aesthetically pleasant and adaptable to different contexts and climate. It reduces the cost and time of construction by using less material and labor, and by avoiding transportation and storage issues, and improve the thermal performance and comfort of building by providing insulation and humidity regulation. Weakness are low market demand and acceptance due to lack of awareness, familiarity, and trust among customers and stakeholders. It faces regulatory and technical challenge regarding its structural stability, durability, and fire resistance. Competition from other alternative and sustainable construction methods such as 3D printed concrete or polymer composite. It requires specialized equipment, skills, and maintenance that are not widely available or affordable. Opportunities: it can contribute to the global goals of reducing greenhouse gas emission, enhancing biodiversity by using renewable and recyclable materials, create new opportunities for innovation and collaboration among architects, engineers, designers, and builders who can leverage digital technologies and local resources, can address the social and economic challenge of housing availability, affordability, and quality by providing customized and accessible solutions for different needs and preferences. It can benefit from the growing awareness and demand for sustainable construction among customers, investors, and policymakers who value environmental and social responsibility. Finally, the threats: the legal and regulatory barriers that hinder its adoption and diffusion due to lack of standard, codes, and certification for its safety and performance. It may encounter technical and operational difficulties that affect its quality and reliability due to weather conditions, material variability, and equipment malfunction. There is negative perception and resistance from traditional construction actors who may see it as a threat to their interests and practices. Vulnerability to external factors such as political instability, economic recession, or natural disasters that may disrupt its supply chain or market conditions. The adaptability of 3D printing has unlimited potentials as highlighted in the SWOT analysis table above. The opportunity to provide automated and customizable building forms within a limited time and with minimal waste cannot be rivaled by any construction method. The examples highlighted showcases the wide range of options embraced by designers and architects to further the availability of the printed buildings in our everyday use. We now look at the 3D printed Adobe application in refugee settlements. My project location is in Nigeria, which is in West Africa, and the project site is proposed to be situated in Borno State in northeast Nigeria. The region is facing a severe humanitarian crisis because there is an overpopulation of internally displaced persons due to insurgency activities in the northeast area and the need to properly resettle them. Key findings highlight the humanitarian consequence of the displacement. This is by gender, by population group, by age, and by people with disability, and the need to provide them with shelter. A look at the rural settlement type shows that these displaced people live in a simple mud buildings with round thatch huts, and sometimes they are built with straws, and they live in clusters of related family units. A look at the weather, you can see that Maiduguri faces an extreme daytime temperature of almost 48 degrees in March and lowest nighttime temperature of about 10 degrees experienced in wintertime by December to January. Fall is experienced between the month of July and September, with peak period experienced in August. For the design proposal, earthen flooring was used as the building system for the floor. 3D printed walls is proposed for the wall construction, while recycled polystyrene roof slab with sprayed concrete and a thatch palm canopy meandering with steel frame for shading and water collection is used as the roof members. A prototype floor plan for a small dwelling unit comprises of a terrace at the entrance, which has a small courtyard for water collection, a living room with a visitor's toilet, a small kitchen, an eating area, and a sleeping quarters with a bathroom within. The fluted canopy is designed to allow for planting of creeping vines so that the housing occupant can plant some of their foods that they eat on them. The section shows a simple geometric pattern that can be easily constructed using a 3D printer. Features can be seen better in the perspective views as shown. Summary. As a management plan for curtailing the global housing and shelter crisis, Adobe printing technology can bridge the gap between cost-effective and sustainable structures in the region. Although more research needs to be undertaken on the adoption and acceptance of the technology by entirely displaced persons, properly constructed Adobe homes taking full advantage of the sun in other active or passive solar systems are extremely energy efficient, at least in areas with a suitable high percentage of sunny days. Implications for further research. There is a large gap in the research on 3D printed Adobe. Further research areas can be on its potentials in space exploration settlement due to their properties, durability, longevity, sustainability, similarities with extraterrestrial environment, and the limitations of building materials. To further buttress on the potentials in space habitation, Foster and Partners Mars Habitat is an excellent example of how 3D printed mud building can be used in outer space construction. The British architecture firm has been at the forefront of this technology, and in 2015, the firm released plans for a Mars Habitat as part of NASA's 3D Print Habitat Challenge and also won the second phase of the challenge in 2017. Advancement in research has also led to the creation of innovative synthetic materials using local components that can withstand enormous weather tests as showcased by AI Space Factory's Mars prototype as shown below. Conclusion. Future prospects for 3D printed mud structures look bright. There's a lot of room for research, especially in areas of regulatory framework, safety, accessibility of technology, and adaptability within various climatic regions. The technology is affordable, environmentally friendly, and it has a great deal of potential to cut down the amount of waste produced during construction. This makes them a desirable option for resettlement structures as well as a fantastic option for upcoming space exploration missions. These properties can be used for buildings that adapt to various environment and climate by using local resources and produce comfortable and long-lasting habitat for humans. I hope you have enjoyed and found this presentation useful. Kindly drop your comments below if you have any contribution or questions to ask. I wish to use this opportunity to thank Professor Dr. Semih Eryildiz for his guidance and mentorship while conducting this research. Thank you.